Hello, and welcome to the Bulbian Review. Today I'm going to be talking about Lux Assessments and how they're crucial for making the right decision for your lighting needs. Lux Assessments allow us to look at the light levels which will be achieved in a given situation using a certain type or types of lights. There are various standards used internationally, such as the Eisner standards from North America, which stipulate the range of lux which should be met for a given area. For example, in the interior of a convenience store, the recommended lux level is 300 lux, whereas some parking lots require 500 lux. It's extremely important that the right lux levels are achieved, as it can expose your work environment to danger by having insufficient light. It can cause obviously injuries and so on, or it can even potentially incur fines for an unsafe work environment. And as health and safety laws are being enforced more and more, it's extremely important that you have that. Not to mention that the morale of the workplace can be drastically changed by using the right or wrong lighting, and that can all be overcome by doing lux assessments. So you're probably asking yourself, what is lux? And well, aren't I glad you actually asked that? Because a lot of people have a misconception of it, or they don't understand it. So historically, one of the first units of measure humans understood was a candle when it comes to lighting. Okay, and the unit of one candle power was equal to the light emitted by a specific type of candle. So one candle power equals 0.981 candela. Or if we round it up, we can say that one candela is approximately the amount of light generated by a common candle. 7 common candles would generate 7 candela of light. Lux and its cousin term Footcandle are measurements of how many candela are observable at a certain distance. Lux levels is pretty much used everywhere else. FC, or foot candles, are primarily used in American-based measurements because it is based on feet. It measures the power of one candle at a distance of 1 foot in a 1 square foot area, whereas lux is pretty much used elsewhere, everywhere else, and is based on meters, or a meter. So what it does is measures the intensity at a meter distance over an area of 1 meter squared. So rounding up again, 1 foot candle can actually be simplified as 10 lux. So you'll find that is the case when you're doing the conversion between the two. Now, let's get the lighting programs to take over and do all the hard calculations. So here I've brought up a model of a hospital that I did just recently. We were required by the architect to do this for AECOM, and had to make sure that the correct reflectance, light loss factor, which is also known as a maintenance factor, and working planes were used. So for reflectance, we used a 80% for the ceiling, 50% for walls, and 20% for the floor. Okay, the working plane was set at 2 feet because that's obviously the approximate working plane as was requested, and the light loss factor was set at 0.9. So I'm just going to show you a few of the things that you can do. And we're actually able to take a CAD drawing. So this was originally just a CAD drawing in 2D. We build up a 3D model by defining wall heights and so on, and then placing the lights. So you can see here, these are lights here. So on the ground, actually, that's what the CAD drawing had. So it tells me where to place it. This has actually no influence on, it doesn't interfere with the reflectance because it's merely a 2D drawing in the background. Whereas these darker lines are defined objects, so the program actually sees it as an object and therefore works off the reflectance stipulated to work out in this case, foot candles. Okay, so secondly, you can see the other light up here. That's actually the light being placed at its right distance. So in this case, it was placed at 9 feet. The walls were extruded to 10 feet. The lights were placed at 9 feet, and the working plane was at 2 feet. So when we did that calculation in this area here, we're getting anywhere between the late 30s to the mid 40s as an average here. Okay, in terms of foot candles, so which would mean around 400 lux. Okay, so that's showing us how that works. Obviously, in different rooms, you'll get different readings simply because different lights are used. So in this area, we were using a 2x2, much more intense light than just a 6-inch recessed. We were achieving, around the 750 lux level, so quite high lux. Now, obviously, in a hospital, certain areas need very intense lux levels or foot candle levels, whereas other areas, don't require as much. And corridors are important; they must be lit up effectively, sufficiently, because the last thing you're going to want as the owner of the building is that people or even passers-by are going to complain about the lighting levels or injure themselves due to poor lighting levels. So this enables us to do that and work that all out. Yeah. So the program is then able to run an analysis based off these factors to determine what the foot candles or lux levels are going to be after we've stipulated what lights we're going to use. So here we can actually put in our lights. Okay, we can define the light loss factor. Like I mentioned, we've done a 0.9 light loss factor. We've done that for all the lights being used in this section of the building. Okay, so that's able to be done. So I'm now going to show you how to build up a model from scratch and show you exactly how actually simple it is to do. I mean, not exactly simple, but you do need the right tools, but what we can offer as a service to you. So let me bring that up. Okay, so starting off, actually, I'll just bring this up and start a new file. There we go, new interior file we get to use. Okay, so I can actually bring in a model now, so I can just do Control I. Okay, and we have here a CAD drawing. Let me just import that. Okay, so we've done that. This is actually the CAD drawing imported into Visual, and a Visual is a lighting program developed by Acuity Brands. Okay, we can erase the information we don't need, so we can get rid of this because all we're interested in right now is not exactly the drawing as the drawing specifics. We're interested in building up a model, so we'll just get rid of the things which are not needed. Simply press E and erase. There we go. Okay, now this drawing is actually slightly, well, not slightly, but it's not in the right scale right now. It is to scale, but it is very large. So, for example, if I move here, I'll just first of all change my environment. I can work between feet if I want, or meters. So I'm going to change that to meters and work in lux. So press OK. Okay. So now, as you can see, the distance between a doorway. I'll just move this as well, so I can move more fluently. Okay, so let's find a single doorway and just show you what I mean. So here, a single doorway starts, if we just do the maths there, we've got the x-axis is 212 minus 204. So we know that the door width is not going to be, what's that, 6, 7, 8 meters. So this is actually, I've worked out already that these doors should be around 0.9 according to physical measurements, and therefore what I'm going to do, I can scale that drawing. So you can always scale it to what you need. So I do modify, I scale it, I stipulate what I want to scale it at, and I already know the calculation here, so it's 9.41. Okay, I select the objects I want to scale, so I'm going to be scaling the entire drawing. Okay, so I've done that now. Go back here. Okay, start my base point, which will be at 0. So X, Y, and Z should all be at 0. Press enter, and there we go. So now, when I actually bring in my light, it'll actually be to scale. Otherwise, before, the light would have been very tiny, because the light retains this meter measurement in the IES file. Okay, so We're going to have a look at this now. I'm just going to bring in the IES file. You can bring this in. This is a 45 watt flat panel. Okay, we'll again stipulate the LLF 2.9 and press OK. Okay. So now we've got a light ready in there, but we don't have any model built up. So what we do, I'm just going to do a section because just to keep it simple. So let's choose a section. We'll do these rooms down here. Okay, so we can have a look. Okay, so what I do initially, I can go here, modify. I can do an extrusion, so this is what I want to start with. Okay, so the extrusion distance at the moment is set to 30 meters, so obviously we don't want that. We'll set that at, let's just say 2.7 meters, or let's just make that 3 meters. Okay, so I can actually now go along and start clicking on the objects I want to extrude. So I'll just do this room here. Okay, I want to extrude that. Yes, in some drawings, obviously the door will be closed there, so you can do that. It's not going to make a huge difference because it's a very small area. Okay, we're going to extrude all this. Don't have to be, just for the purpose of this, I'm not going to be entirely specific about what I'm clicking on, but just to get the basic room structure. Okay, there we go. If I right click now, that's now turned into a model there, as you can see. Okay, but it is merely just a background model. Now we've got to actually turn that into a solid. So how do we do that? We click on Modify, Convert, and Solid. Okay, now I can click on these again on the same lines. Now a faster way to do it is you can go like this and select everything, but sometimes, as you see here, some of the other background objects for some reason actually turn into a solid, but we can change that later. If I can right click now that's turned into a model there, as you can see. And just to get rid of those zeros, I will go back here, do Modify, Convert, and Background. I wanted to convert these back into a background, so I'll select them. There we go. So now when I do my assessment, it's going to do it more accurately. To place a light, I click on here. Okay, the mounting height here says 10 meters. Okay, so I need to just change that back. We'll mount it at ceiling height, 3 meters. And now I can just place it. Go ahead and place it. So let's just put 2 lights in there. Okay, there we go. So that's 2 lights. We can do a calculation now. Calculate zone. I can do a polygon shape. Okay, so the working plane, I might want to put this one at, let's say, 0.9 meters because we're in meters now. Row spacing, that's to do with how many points you want to observe on your screen. Okay, so I might set that at 2 meter spacing is fine. So first calculation point, you can be approximate here, so just click outside of the area, so around the perimeter of the room, that back on target here. Okay, so as you can see here, the points have come up, so it's going to give me 4 points of calculation. Now obviously when I'm doing a large building, I might want to change that into 4 meter distances or 2 meter. It depends on what you're assessing, but for a small room it's fine. Go to calculate. It'll do a surface analysis, photometric, geometric, and so on. And here we're finding we're getting a lux level of 214. So depending on what's going on in that office, that may actually be a sufficient lux level for that office. Okay, if it's not, let's say it's more of a high intensity office or a high intensity workflow and you need more lights, then we might need to consider putting 3 lights in there or even 4 to get up to maybe the 500 lux level. Okay, so that's that. Now what you can also do in this program is, if I wanted to, I can do arrays of lights. So the last thing you want to do is to, let's say we were doing this section here and you had to place all these lights. You're not going to want to click each one, go through it, this, it doesn't line up properly. So what you can actually do, I'll just go back here, I can do an array. Okay, so I can say, okay, well my spacing I know my spacing. I want it at every 2 meters in both directions. Okay, this is just approximating. I click on the object that I want to do that for. I do a right click, then a left click, and I can just drag it. So now I can do it nice and evenly in that area there. Okay, so if I had built up a model there, it would have done it can do the calculation there as well. So that in brief is how this works. The benefit of doing these assessments digitally is that it saves you and your company from having to fit out your building with the lights you want to use, only to find out that they are not going to meet standards. So you can save yourself money, time, and effort by getting these assessments done beforehand. Okay, and just to explain a bit on the IES files, what it is, an IES file contains photometric data of the light being used. The program then is able to run an analysis based off these factors to determine what the foot candles and lux levels are. So the IES file is critical, and it's important that the IES file is done or developed in a proper situation, because it is possible to manipulate IES files. So you've got to be careful where you're getting them from, and that they're reliable sources and so on. Okay, so we can offer the service from Bulbian, and we are able to offer this internationally, given that it can all be done on the computer. As long as we are able to get your CAD drawings, we're able to offer this and cater to any situation, including but not limited to things such as offices, warehouses, tunnels, roads, and even for a simple residential situation. So please contact us via our website, which is www.bulbian.com.au, to get started on assessing your light levels. Thank you.